Hello, students. I wanted to go over chapter 1, and what I'm going to highlight is a little bit about what physics is. I'm going to jump into the metric system, a little bit of scientific notation, and then I'm going to talk about conversions. And that's basically the main things that I want to make sure that you understand from chapter 1. So what is physics? I'm also following along with your book. So physics is basically a big branch of science. The word science comes from Latin word of having knowledge, but it refers to the knowledge of how the physical world operates. So kind of makes sense, physics, the physical word. So it's basically a way of explaining our everyday world, how we move, all the physical properties, how we move, what is sunshine, how we hear, all kinds of things. So it's a science that's aimed in describing the fundamental aspects of our universe. So it means what things are in it, what kinds of properties that are noticeable, what things the properties undergo. Basically attempts to basically describe the basic mechanisms that make our universe behave the way it does. Why does the apple fall from the tree straight to the ground? Why doesn't it, when it pops off, float in the air for a while? So there's all, basically that's what physics is. So you can use physics to understand everything in your everyday life. But physics has come a long way. So it's expanded into many branches. The ancient people, they were trying to figure out shadows, why things were able to be upright, the stars, that was the main thing. So it's been diversified more and more. They also include branches such as sound, which is acoustics, optics, the study of light. It's gone into electromagnetism. Electricity is huge. So there's all kinds of things. But so physics is just explains the world that we live in. And so by studying the most important topics in physics, you'll gain the analytical ability that will enable you to apply physics far beyond the scope of what we're going to be teaching you in this class. But the skills are going to help you excel academically, and they'll also help you think critically in any career you pursue. So this is still a part of your chapter, but I'm actually going to go into the metric system. So I'm going to pop in some other slides. It's just a little bit easier. So your book goes through the entire metric system, where it came from. So we basically have two different systems that you can use to measure in physics. So one is the metric system, and the other one is the British system. So the International System of Units, that's called the SI system, that's the metric system. And the other one is the British system, which is your inches and your feet and your foot pounds and things like that. All of physics is taught in the metrics, the SI units, which is the metric system. So why? Because it's a really easy way to calculate things. For instance, if you look at this chart right here, metric examples versus British examples. So 1 kilometer is 1,000 meters, fairly simple. But 1 mile, that's not 1,000 feet, it's 5,280 feet. So you have to remember a lot of different things. 1 meter is 100 centimeters. 1 yard is 3 feet. 1 liter is 1,000 milliliters. But 1 quart, which is the similar one, is either 32 ounces or 2 pints. And if you compare 1 liter to a gallon, 1 gallon is 128 ounces. So you can see, if you just looked at the meter ones, 1 kilometer is 1,000 meters, 1 meter is 100 centimeters, 1 liter is 1,000 milliliters. it's fairly simple. They kind of go together. And it's really convenient because they're all based in the number 10. One of the main ones is a kilogram. If you really want to know the difference between a kilogram, so the kilogram we use all the time to measure our mass in grams and in kilograms or in milligrams, whatever it is. But the original kilogram was found to be the amount of water that is held in 0.1 meter cube. So 1 kilogram is equal to 1,000 centimeter cubes of water. And then they basically weighed that. There's also a metric ton, the mass of 1 meter cubed of water. That's what they consider a metric ton. 1 meter is 100 centimeters. So basically, you can basically say that 1 kilogram times 1,000 is 1 metric ton. I really don't think we really use metric ton too much anymore. So as long as you understand a kilogram, that's really all I need you to do. So units and conversion factors. Another reason why you want to use the metric system is that it'll be much easier to convert if things at least have meters in them, rather than giving you a unit in inches or foot and then you have to convert it into meters and things like that. I just wanted to bring apart some unit combinations. So sometimes you'll have more than one unit at the end of a given identity. So the Newton, which is the unit that we reference forces for, which will come up very quickly in this course, and that is the mass times acceleration, which you don't know right now, but the unit is a kilogram meter divided by a second squared. So instead of always writing down kilogram meter divided by second squared when you solve a problem, you can just replace it with the big capital N for Newton. Another one that they use a lot is joules. So joules, instead of having to write kilogram meter squared divided by second squared, you would just write a joule. Another one when you're working with things is watts. So a watt is also power, but that would be kilograms per meter squared divided by seconds cubed. So you don't want to keep writing all of these units, so that's why you look at the combination, and that's what a watt is. Now we are going to have conversion factors. I'm going to try to keep it more simple for you, and that's really more of if you have a centimeter and you're going to try to figure out velocity soon, it would be distance over time, and your distance would be in centimeters. You got to put that into meters. So it's very, very important that we go over conversions. I don't know why there's a picture in here. So one of the easiest conversions is 1 inch is equal to 2.54 centimeters. So if you are given something in inches, you need to convert it into centimeters. So first steps to conversions is you want to use a conversion factor that can generally be looked up. And then it's about arranging so that it's in its proper form. Then you're either going to multiply or divide to calculate the answer, and then you should be able to calculate the answer. So in this example, we wanted to convert 50 kilograms per hour into miles per hour, which I would be going the opposite because we're not going to be using miles per hour, but this is the example. So how fast in miles per hour is 50 kilometers per hour? So there's a conversion factor which you would look up in a table, and you have several of those in your book. So 1 kilometer per hour is 0.62 miles per hour. So this is known as a form. So there is an equal right there. So you can easily rewrite that. So 1 kilometer per hour equals 0.621 miles per hour is the same thing as looking at it this way. That means 0.62 miles per hour is equivalent underneath to 1 kilometer per hour. So you can rewrite these factors this way. And the reason why is if I started with kilometers per hour right here, then you want to be able to get rid of the kilometers per hour. And so if you're dividing by kilometer per hour, you're basically going to take out those units. And you'd be left with the miles per hour. So whenever you're using conversion factors, you got to look at the unit you're starting with and make sure the conversion factor is in the form where the same units are underneath so that you're doing it properly and converting everything properly. And so if you put that in your calculator, all you do is multiply 50 times 0.621 and you should come up with 31.05. And then you cross out the kilometers per hour, they get crossed out, and the miles per hour is left. So this is going the reverse. You have 50 miles per hour and you want to know how many kilometers per hour it is. So again, you have 1 kilometer per hour is 0.62 miles per hour. You can use the same one, or you can use the 1 mile per hour is equal to 1.61 kilometers per hour. I think this is very confusing. I usually keep the same conversion factor and I just apply it. So if I was using the same conversion factor, I would use the top one. I have the 50, now I have miles per hour here, so I need to put the conversion factor in the proper form. So if you look at here, now I have the 0.621 miles per hour at the bottom because I'm trying to match it with the units that are present so that basically it's so I can convert it to kilometers per hour. And so these are going to divide each other out. But the one thing you have to know is that you're going to be actually putting your calculator 50 divided by now 0.621. And you should come out with the 80.5 kilometers per hour. Sometimes you'll have multiple step conversions, and that's not a problem. So you have 22 inches, but you need to get it into meters. Well, 22 inches, we know 1 inch is equal to 2.54 centimeters. So if you put this conversion factor here, now you're going to get rid of the inches, but now you'll have it in centimeters. And so you either have to do the centimeters, now you've got 1 meter is equal to 100 centimeters, or you can also put the unit in scientific notation. But I just want to make sure everyone can understand. So 22 would be multiplied by the 2.54, and then you're going to divide by 100. And then you should be getting the 0.56 meters. Let's see, what else did I want to do? All right, I think I'm going to stop this here. In the next video, I'm going to do a bunch of examples of conversions, some conversions, and then I'm also going to do problem-solving steps because you definitely need those.